Welcome to a new video in our series, A Beginner's Guide to the C Programming Language. In our last video, we discussed pointers and how to use pointers to access memory indirectly. We also saw various applications of pointers in C programs. The video today covers strings in C. Strings are not a basic data type in C, which means that you do not have inbuilt operators and functions to perform string manipulations. The topics covered today are strings and how to declare them. Then we'll discuss the string library functions and see how to perform operations on strings using custom code. Please like and share this video, follow our channel and subscribe for notifications on new videos. A string in C is defined as an array of characters that is null terminated. You know how to declare an array, but an array of characters is not necessarily a string. To be a string, it has to be null terminated. That is, the last character of the string should have a zero value. This null terminator is immediately after the last character. Any data to the right of the null terminator is not part of the string. Note that the strings we are discussing today are byte-wide strings. They contain characters from the ASCII character set. As mentioned in an earlier video, another character encoding scheme is Unicode, where characters have 2-byte or multi-byte values. These characters can be used to display strings in multiple languages. Since a string is not a basic data type of C, you cannot perform operations on them directly using regular operators and inbuilt functions. Instead, you need to write the string manipulation function yourselves or use a string library function if available. You declare a string just as you would declare a character array. However, you need to estimate the largest length of the string you will hold in that variable. The size of the character array should be at least one more than the largest length it will hold. This additional character is for the null terminator. When you initialize a string, you can initialize it with a string constant as shown here. If the initialized value is the only value the string will contain, then you can declare it as a char pointer. In this case, the compiler calculates the length of the string and allocates exact amount of memory for the characters and the null terminating character, and the address of that memory location is stored in the character pointer. Let us start with some simple functions in the string library. The first two functions are getS and putS. The function getS gets a string from the keyboard. This function is passed the starting address of the array. It updates the string with the values of the key pressed on the keyboard. When the user presses the enter key, it null terminates the string and returns a pointer to the start of the string. Similarly, the function putS displays a string on the console. The string to be displayed is passed as an argument to the function. As shown in the program here, we simply input a string and then display the inputted string on the console. The next set of string functions are the strcpy, strncpy, and the strcat functions, or the string cat function. Like all string functions in the standard C library, these functions are declared in the header file string.h. This file must be included in the code as shown here. The strcpy and strncpy functions copy a string to the destination string. It is similar to the assignment operator. The string copy function takes two arguments. The first argument is the destination string. The second argument is the source string. The function copies all the characters up to and including the null terminator to the destination string. Note that in all string functions in C, the functions have no way of knowing how much memory is allocated to the string. It is the responsibility of the programmer to allocate enough memory for the destination string. If the string overflows the allocated memory, it results in runtime errors. The strncpy function is similar to the strcpy function. The only difference is that it takes an additional argument which specifies the number of characters to copy from the source string. Note that if the source string is larger than the number of characters specified, then the destination string is not null terminated and must be null terminated after the function call as shown here. Finally, the string cat function is the string concatenation function. It appends the string 2 argument to the end of the string 1. The string 1 is the first argument to the function and string 2 is the second argument. Again, you should make sure that string 1 is large enough to hold the concatenated string. Let's check this out with a small piece of code in the debugger. Let's single step through this code. The first call to strncpy will copy only 5 characters from the string hello world. The string str will only contain the string hello. Watch the values in the watch window. As you can see, the string is not null terminated and needs to be specifically null terminated after the function call. The second call is a call to string cpy. The entire source string is copied to the destination string. Finally, the third call concatenates a string to the original value of the first parameter in str. The final result of the value in str is shown here. As you can see, this value is the concatenated value of the two strings. We will now learn how to perform relational operations on strings. That is, compare the values of two strings and check for greater than, less than, and equal to operations on strings. The functions that compare two strings are strcmp. It compares two strings and returns a negative value -1 if string 1 is less than string 2, 0 if string 1 is equal to string 2, and 1 if string 1 is greater than string 2. Note that both -1 and 1 are both logical true and 0 is logical false. So to check if string 1 is less than string 2, check the return value of strcmp for a value of less than 0. To check if it is equal to, then the return value will be equal to 0, and greater than will return a value of greater than 0. For less than or equal to, check for less than or equal to 0. For greater than or equal to, check for greater than or equal to 0. And for not equal to, check for not equal to 0. There are different versions of the same function. The function strcmp is a case-sensitive compare. That is, uppercase A is not considered to be the same as lowercase a. The function strcmpi ignores the character's case when comparing. It treats a uppercase A and a lowercase a as the same. Otherwise, it behaves exactly similar to strcmp. The strncmp function compares the first specified number of characters of a string. The number of characters to compare are passed as a third argument. Similarly, the strnicmp function ignores case during comparison. The string library in C contains many utility functions that are very useful when processing strings. Let's have a look at a few of them. I would urge you to look up all the string functions in the standard C library and understand their functionality and usage. We will look at a few of them. strlen function returns the length of the string. It simply counts the number of characters in the string until it reaches the null terminator. Note that the length of the string is not the same as the size of the character array, and the length of the string does not include the null terminator. The function strupr converts the input string to uppercase. This function modifies the string that is passed to it. Similarly, the function strlwr converts the input string to lowercase. Finally, the strrev function reverses the string. Now let's look at how to process a string using custom code. Sometimes you may need to write your own code to perform a desired operation on a string. This may be because a functionality you need is not available in the standard C library. In this case, you will write a function that performs the required operation. For example, out here we are replicating the string len function that returns the length of a string. As you can see, the function receives the starting address of the string. The variable len is initialized to 0. The function then counts the characters in the string until it encounters the null terminator. The length is then returned to the calling function. Let us now work with strings in a small piece of code. The program written out here checks if a string is a palindrome and displays the result. As you know, a palindrome is a string that reads the same backwards. Here we will input a string using the getters function. Then we will call a user-defined function that will strip all the spaces from the inputted string. We then will convert the string to lowercase, make a copy of the string, and then reverse the copy of the string. Then the two strings will be compared. If they are equal, then the string is a palindrome, else it is not. Here we go. Let's input the string, then call the function to strip the spaces. Let's single step through this code. As you can see, we copy all characters except for the space character to the same string. Then the string is copied, reversed, and compared. The final output is displayed here. Let's try again with a string that is not a palindrome and single step once again. As we go through each of the operations, check the watch window for how the data is transformed after each operation. Also pay attention to the program flow. The final result is shown here. We have reached the end of our discussion on strings. We looked at how to create strings and performed various operations on them using both library functions and custom code. Please follow our channel, like and share this video, and click on the bell icon to receive notifications. In the next video, we will learn how to work with files in C. See you then.